Okay, Assalamualaikum warahmatullahi wabarakatuh. In this lesson, we are going to understand the total internal reflection, which is a very special effect of optics. Alright, so let us consider again light coming from air interface. This is air, and this is water. So light coming from air at certain angle, incident angle, and it reach the water. Alright, so by the law of reflection and refractions, we can have an incident ray and also reflected ray. And also, because water is a transparent, so there will be a refraction occur here. So we will have refraction. Alright, so how the refracted, where would be the refracted ray? Is it straight? Is it away from normal? This is normal. Or is it closer than normal? Alright, so by observation, because water is it has a higher refractive index, so the light should be refracted closer to the normal. Okay, so it should be like this. So it has reflection and it also has refraction. And also from the law, we know that the incident angle is also equal to the reflected angle. So that is for reflection. For refraction, we have to calculate the refracted angle. How can we calculate? We can use Snell's law. Okay, so this is Snell's law. From the third law of reflection and refraction, it said that n1 times sine theta 1 equal to n2 sine theta 2. So this is from the Snell's law. Okay, so for example, you are given this is 15 degree. So you have 15 degree incident angle. So calculate the refracted angle. So how are you going to calculate? Okay, because this is air, and air it has n equal to 1. This is for air. And for water, it is 1.50. Sorry, that's for glass. So 1.33. Okay, so now we have a refractive index for air, refractive index for water. You are given theta is equal to 15. So from the Snell's law, so you see this is the first medium and the angle is in the first medium. So this is 1 sine 15 degree. Now 1 sine 50 degree equal to 1.33 sine theta r. Okay, right? So this is water, index in water, angle in water. Index in air, angle in air. This is index in water and angle in water. So by calculation, make sure that your calculator is set in mode degree. In chapter 1, you usually use mode radian. But in this optics, we have to use mode degree. So make sure your calculator is set at mode degree. So you can have 15 and 11 degree. So you see the 11 degree is smaller than 15, right? This is logic. That means this is 15 and this is 11 degree. Alright, so it is closer to the normal. So try out for 15, 30, 45, 16, and confirm by your calculations. So you will have the refracted angle for each value will be 11, 22, 32, 41. Okay, so you can see that refracted angle always smaller than the incident angle. Okay, how about if the light coming from water, or in this case, light coming from the low end to high end? How about if it's coming from high end to low end? For example, from water to air, from glass to air, from glass to water. Okay, how about that? Okay, so same thing occur because we will also have reflection, where the reflected angle is equal to incident angle. So that is for reflection. How about the refraction? Okay, so is it going straight, away than normal, or closer than normal? So since this is lower index, so we should expect that the refraction should be like this, away than the normal, right? this is closer than normal, this is away than normal because it's from high index to low index. Okay, so it should be like this, right? So this is refraction, this is reflection. So this is the angle of refraction. Okay, so same like this, if you are given 15 degree, okay, what will be the refracted angle? Okay, so same formula, but you have to use it correctly. Okay, so this is index of water, which is 1.23, angle in water, which is 15, equal to index of air, 1, and sine angle in air. Okay, so you use that, you will get 20. So it's logic, right? If this is 15 degrees, you will have angle larger than 15 degrees because it's away than it's going from high index to low index. Okay, so you see, even though you use the same formula, you will have different value. So make sure you can plug in the value correctly inside this formula, because if you do include incorrect information, you will have different answer. Okay, so if you have 15, you have 20. So when you increase the angle, you have 42. When you increase more, 55 degree, it will be refracted more. But when you have 60 degree, when you use your calculator, you will get error. Okay, so what does it mean when you get error? Alright, so when you increase the angle, and this also will refract further, there is at certain degree, the refraction angle is maximum 90 degree. Okay, maximum 90 degree, so it cannot refract. Okay, so that is the situation like this. So there is an angle where the refracted ray becomes 90 degree. Okay, so that angle is called critical angle because the light will not be refracted anymore because it's a maximum. Okay, so that angle is called a critical angle. Alright, so how do we determine the critical angle? Same, you use this formula, Snell's law. So the angle, this is the first medium, which is in this case water. First medium and 1, sine theta c. This is critical angle. And this is the medium here, sine 90 degrees. 90 degrees, this means the refracted angle is 90 degrees. Okay, so when you have like this, critical angle is equal to sine minus 1 n2, which is this is n2 divided by n1. So sine 90 degrees is equal to 1, right? So you have you can determine the critical angle equal to like this. Okay, so return back to the situation, water and the air. For example, you have a water and 1.33, and this is air. By using this calculation, you have critical angle is 49 degrees. That means so it means that if your incident angle is 45, you still have refraction. But when you reach 49 degree, the refracted angle become maximum like this. But if you go further, you will have total internal reflection. That means, in this case, if you have incident light, your light will go refracted and reflected. You have both. But when you have when your angle is larger than critical angle, all light, for example, this is an angle which is larger than critical angle. So all light will be reflected. Okay, so all light, that means total. Total internal means internal, inside, and reflection. So that means before critical angle is reached, light can be refracted and reflected, but when the incident angle is larger than critical angle, all light will be reflected. So that is called the total internal reflection. All light will be reflected down. Okay, so this is for water and air. If we have this is glass and this is air, the value will be different. Okay, so try it. If you have what glass and air, so it will be 1.5, and your critical angle should be 42. That means your critical angle will be lower than water. Okay, so if you look into this situation, total internal reflection cannot occur in this case. It only occur in this case. So we can have conditions for total internal reflection to occur. So what will be the condition for total internal reflection to occur? The first condition is that light must coming from higher index medium. Okay, so light must coming from higher index medium. That means from glass to air, from glass to water, from water to air. From air to water, the total internal reflection cannot occur. Okay, the second condition is that incident angle, is larger than critical angle. So the incident angle must be larger than critical angle so that the total internal reflection can occur. So what would be the importance of this phenomena? It is very important in fiber optics. Alright. So in fiber optics, internet, our fast internet use light for transmission. Okay, so fiber it makes of glass. So this is glass, and this is just air or environment. So when you have internet in form of light, so it will be transmitted like water. So the angle, so the angle of incident must be larger than critical angle. So that means the light will be reflected inside the medium forever. Okay, so in fiber optics, lights become like a water in a tube. So the light cannot escape because of this phenomena.